Metric prefixes and SI units. In building biology, you're often going to deal with numbers that are either very large or very small, especially when it comes to air sampling and electromagnetic fields. So I just want to revise how we deal with these numbers so that you can familiarise yourself with this when you get to those subjects. For example, the current flowing in a circuit can range from a few millionths of an ampere to thousands of amperes. Now we have here prefixes and symbols that relate to various standard number formats, or what we call metric prefixes. Tera, which means monster, use the symbol T, and it relates to 1 trillion. An example of that would be 4 terabytes. So we mean 4 trillion bytes. We use those terms, for example, when we're referring to a hard drive in a computer. Giga or Geiger means giant, and the symbol we use is G. It relates to 10 to the power of 9, which means it's 1 billion. So, for example, 2.5 gigahertz. Gigahertz, of course, this frequency is used in wireless technologies, such as a wireless router, for example. So 2.5 gigahertz, 2.5 billion hertz. Mega means great, and we use the capital M. It's 10 to the power of 6, and it means 1 million. For example, 1900 megahertz. This could be used, for example, in a cell phone, depending on, of course, the carrier. So 1900 megahertz is 1900 million hertz. And that's how we refer to it. So mega means million. Kilo or 1,000, you're probably familiar with that. When you buy 2 kilograms of apples, you're buying 2,000 grams of apples. Kilo is a small k. It's 10 to the power of 3 because it's 1,000, 1,000. For example, buying your groceries. So that's the high end of the numbers. At the low end, we have the following. Pico means small, it's a small p that is the symbol, and it's 10 to the power of minus 12. So that's a trillionth. For example, 4 picocuries. Picocuries is a formation or a way of describing radioactivity. Nano is 10 to the power of minus 9, which is 1 billionth, not a billion, but a billionth at the other end. So when we talk about nanoparticles, we're talking about the size of actual particles being 1 billionth of a particle. For example, the use of titanium oxide or dioxide in sunscreens are often used as titanium dioxide nanoparticles. So they're a billionth of whatever the metric is. Micro, we use the symbol U, and it's 10 to the minus 6, which is 1 millionth. So when we refer to as micrometers, for example, with allergens, for example, how many micrometers there are, it's actually 1 millionth of a meter. Another example is 10 microns would be a size of a mold spore, or 70 microns would be the size of a pollen. Microns meaning 1 millionth of an actual meter. The last one is milli, and that would be the small m, and that's 10 to the minus 3, which is 1,000th of whatever the metric is. For example, 0.2 milligauss is a term we use to measure AC magnetic fields, and that means a 1,000th of a Gauss. Or if we're talking about millimeters, it's 1,000th of a meter. So these are symbols that you should be familiar with. We do use them, especially with air sampling and electrobiology. And I like to, this is how I learned, is to put it in the one table. So pico is 10 to the minus 12, whereas tera is 10 to the power of 12. So pico is the smallest, tera is the largest. It's not often we're going to deal with that type of standard number format. But nano and giga or Geiger, we certainly do, and that's 10 to the power of 9. So nanoparticles will be 10 to the minus 9, and gigahertz, for example, would be 10 to the power of 9, i.e. 10 with 9 zeros. Micro, 10 to the power of, is 10 to the power of minus 6, so 0.000001. Mega is 10 to the power of 6, which is a million. Milli, of course, is 1,000, which means 3 zeros. So if it's milli, it's 0.0001, and if it's kilo, it's 1,000. So that's kilo, and that's how I like to remember this, is to look at this table and look at both the extreme one end to the minus and the other one to the end. You should actually learn this because it will make it easier as you go through subjects like air sampling and electrobiology. For example, 2100 megahertz, it can be converted to 2.1 gigahertz. So we know mega is 1,000, but giga is 1,000,000. So therefore, we go from 2.1 to put it to 2.1, we have to divide it by 1,000, and then we get 2.1 gigahertz. And if we convert that to terahertz, we have to go then another 3 zeros in that direction. So 2100 megahertz is the equivalent to 2.1 gigahertz, which is equivalent to 0.0021 terahertz. Another example in radio frequencies is 10 watts per square metre is equivalent to 10,000 milliwatts per square metre, which is equivalent to 10 million microwatts per square metre. Now, in the building biology standards, when we're measuring radio frequencies, we use microwatts per square metre, but the government standards are actually in watts per square metre. So we need to be able to convert it to be able to make sense when we're talking to our client and when we're taking measurements. Another example is Teslas. 2 Teslas equals 2,000 milliteslas, which equals 2 million microteslas, which equals 2 billion nanoteslas. And many of your Gauss meters will measure in nanoteslas, so it's important that you are able to convert from one metric to the other, especially when you're looking at the exposure standards. The other one, of course, is milligauss. 1 milligauss equals 100 nanoteslas. So things like that you will rote learn as you go through the various subjects. Scientific notation is another way to express the prefix in mathematical form by using scientific notation. Each prefix is treated as to the power of 10. For example, 1,000 can be written as 1 by 10 to the power of 3, and that's equivalent to saying 1 times 1,000. 3 million could also be written as 3 by 10 to the power of 6, because it's 3 times 6 zeros. 150 million kilometres could be written as 150 by 10 to the power of 6 kilometres. And this is the way you would actually write it in scientific circles and, of course, when you're liaising in building biology. To express the following numbers in scientific notation, we will do it as follows. 341,680 would be expressed as 3.4 by 10 to the 5. 978 would be left as 978. 0.000077 would be written as 7.7 by 10 to the minus 6. So being able to convert like this and write it more simply is really important. Lastly, when we're looking at fundamental units, we're looking at things like length, which we measure in metres, and the symbol for that is m. For mass, we look at it in terms of kilograms, and we use kg. Time, we measure in seconds, and the symbol of that is S. Temperature, we tend to measure in degrees Celsius, not Kelvin, but in scientific circles, they'll often use Kelvin as the unit. The electric current will measure, the name is ampere, and the symbol is A. Frequency, we will use the hertz, and it'll be measured at the symbol will be Hz. So how many frequency, we use 50 hertz frequency, for example, in our building wiring and in all our appliances in Australia. Force, the name is Newton and the symbol is capital N. Pressure, we use the name Pascal and the symbol is capital PA. Power is normally measured in watts and we use the symbol capital W. Energy is measured in joules and the symbol is J, capital J. And temperature I mentioned is degrees Celsius and that's normally a 0, that's superscript and capital C. For the electric charge we normally use the term coulomb and the symbol is capital C. For electric potential, which is voltage, we'll use the term volt and we'll use a capital V. For the electric current, we will refer to that as amps and use the capital A. And for electric resistance, we use the term ohm and use that symbol. As you can see here, the energy, joules, capacitance, farad. These other ones we don't use very often, except the last one, flux density. The power flux density of magnetic fields, AC magnetic fields, we do use. That's the unit of measurement we use, and normally we measure it in either Tesla or Gauss, and the symbol for that is either capital T or G.